When we use Kotlin coroutines in our code, we will inadvertently at some point start using structured concurrency principles. Kotlin coroutines don't necessarily need to use this principle all the time. It really depends on the scope that you want to use. Some scopes are better suited for structured concurrency, while others are not. But before we can continue and move on to understand what structured concurrency actually is, we need to understand about scopes. We need to have a good understanding how scopes work and what are they. And perhaps it's important also to understand what scopes are outside of coroutines, because we will realize that we use scopes all the time and that the principle is the same if we apply it to Kotlin coroutines. So let's say, for instance, you are giving a presentation, and in that presentation you need to keep talking about a certain subject. Someone in the audience will ask you a question, and you will divert your attention to something different, and you will start talking about a different topic. You have moved there off the scope. That's what we say, but that is true. Your scope is the topic of your presentation, not the topic of the member of the audience that asks you a question about something slightly related, but not the actual topic of your presentation. The same thing goes if you think about something more closer to us as developers. When we talk about Scrum and the way the sprint works. When we've got tasks in a sprint and different stories to make in a different sprint, we are committed to complete all of these stories at the end of that sprint. But sometimes there is something called a scope creep, because maybe we didn't foresee something coming, something that's necessary, something that we discussed with product, and product tells us, no, that needs to be done right now. If that is the case, then there is a scope creep. The scope has changed. And that means that the scope that was strict under those boundaries, under that estimation that we made to the end of the sprint, now needed to expand a bit more. That is a scope creep. So we can see a common denominator here, and that is that scope restricts things. It makes things work under that range, that area, that plane. And so that is part of a regulatory thing that we do in order to limit, and in order to be able to manage how we work. Now, the same applies to coroutines, of course. Coroutines need to work under certain boundaries, and that is what scopes do for coroutines. And there are at least 5 coroutine scopes that are very important in Kotlin coroutines. There's the GlobalScope, the normal coroutine scope, the supervisorScope, the MainScope, the viewModelScope. The first 3 scopes we can use in server-side, and the last 2 we will see examples of them in Android. The MainScope we can use in other different applications, as we have seen in previous videos, like for example in Swing applications, but we are using that now in an example in Android, and the last one is specific to Android. So let's have a look at these examples. The first one is the GlobalScope. It is important for us to understand the GlobalScope because it's the only scope where structured concurrency will not be able to occur, and we will see that right now in the following example. So let's get into that. So this is again the project that contains all the different examples that we have seen in the different videos. I have created in the meantime a module called Coroutine Scopes, and this is where we are going to see the different examples for server-side development. Again, they are the GlobalScope, the Coroutine Scope, and the supervisorScope. But now we are looking at the GlobalScope. And the example that we are looking at specifically is the cancel on GlobalScope. Again, the location of this repository is JE or Kotlin test drives on my GitHub handler, j.esperancina. And you will find this on GitHub. The links are already, as usual, in the description. Let's continue. So I have here an example that contains 2 different objects. This file contains object cancel on GlobalScope, and it also contains another object called cancel on run blocking. I also have another extra object, which is called cancel on example, and the cancel on example will run the two different examples. What we want to see now is a critical difference between the GlobalScope and how we normally run Kotlin Coroutines. The GlobalScope has interesting characteristics that we can use, for example, for monitoring and for logging. I actually talked about the GlobalScope very briefly on this video right over here. It was a great day in Gouda, and there I discussed one of the interesting features about the GlobalScope and why should we not use it and why we should use it. It really depends on the situation, but normally we should actually not use the GlobalScope. So I've got here one example that we are using it, and we will see very quickly why the GlobalScope can be an advantage or maybe not an advantage. One of the things that IntelliJ highlights already is the GlobalScope here. And what it says to us is to opt in for Delicate Coroutines API. And the reason for this is that GlobalScope has an interesting characteristic, and that is what we see over here. It's a delicate API, and it says here a global coroutine scope not bound to any job. GlobalScope is used to launch top-level coroutines which are operating on the whole application lifetime and are not cancelled prematurely. So we already have here a warning that we are not able to cancel these coroutines because they don't belong to any life cycle, but it also says that they are not cancelled prematurely. Canceling prematurely may be something that we are interested in because it's actually a part of structured concurrency. But it goes further. Active coroutines launched in the GlobalScope do not keep the process alive. They are like daemon threads. Daemon threads, they were kind of like daemons in Linux. They're basically just running as background processes. And the thing about them is that they will not work correctly with structured concurrency. And that is something that we can read right over here. This is a delicate API. It is easy to accidentally create resource or memory leaks when GlobalScope is used. A coroutine launch in GlobalScope is not subject to the principle of structured concurrency. So if it hangs or gets delayed due to a problem, example given, due to a slow network, it will stay working and consuming resources. For example, consider the following code. This is one example that they give us. It is called load configuration, GlobalScope launch. And it goes further to tell us that if any of these processes hangs and we call it again, it will just accumulate different resources that will get stuck in the GlobalScope, and it will steal resources from our machine that we otherwise would be able to use in our program. But let's go back to the concrete example that I created so that we can understand this a little bit better. So when I start the program, the first thing that I do, I will print out the context of the GlobalScope. The GlobalScope has an interesting feature. It's available everywhere and we can access it just like a static variable. It is available from anywhere in the system. And from it, we can launch coroutines. And here's already something that is slightly different because we don't need to create a scope to launch the coroutines. The GlobalScope itself, as a static variable or kind of a static variable, is already available to launch these coroutines. If we go inside GlobalScope, we see that it is an object. So it kind of is something static that is available for us to use from anywhere in our code. And what I'm doing here is simply launching a coroutine scope, and then in that coroutine scope, I am launching another coroutine. So I've got one here running inside the coroutine scope, and then I launch here, and then I print out the current thread and the context of that coroutine. This will delay for 1 second, and then it will print out that this coroutine will be cancelled. The thing is, it will never reach this point because it will throw an exception right over here, and it will maybe cancel everything or not. This is something that we will see right now. And at the end, it would have otherwise printed this out or this, and then it would have slept for 2 seconds, and then finally it would have printed still running. Now the thing about GlobalScope is that because it is not attached or it doesn't follow the principles of structured concurrency, it will just keep running. So it will not wait for the coroutine scope to continue. So that means that when we launch this, it will just continue running. It will finish off the program execution. And the only reason why the program will continue is because we will sleep for 2 seconds waiting for the thread that is running this process over here to finish off, so that it then prints out the result of this exception. I will run this now so that we can see clearly what I mean with this. Let's just run the cancel on GlobalScope example separately. We can see that the exit code is 0. We can see already an exception. So what that means is that the GlobalScope has ignored the result of this launch. The exception has been propagated all the way up to here, but not further. So that means that the GlobalScope will just ignore it and print out to the console this exception. And here it continued. It slept for 2 seconds, and here there was a delay of 1 second. So this is why we get all of these printouts. First, the parent thread, this current parent thread, is this printout over here. This current thread over here, thread number 32, this one has been printed out at this point, and this one has been printed out at this point. And because this has been cancelled, structured concurrency did happen in Coroutine Scope. That's why we don't see any printout of this will be cancelled. If we look at all the logs, we see that we don't have anywhere this will be cancelled text. We can also observe another thing. The GlobalScope has an empty coroutine context. And this means that when we start a coroutine on this scope or from this scope, it will start with Dispatchers.Default, which is what we see right over here. If we run here to this side, we can see that these threads have started in Dispatchers.Default. All of them. We can also see a different thing, is that the launch here has a different thread than this launch and has a different thread than this bit over here. So we've got actually 3 threads running at some point in time, and they are all running in parallel. But what would be the difference between using a GlobalScope and using run blocking? As I said before, GlobalScope does not have any understanding of structured concurrency. So what that means is that it continues to run without any understanding of a cancellation. But if we do this with run blocking, which is the example that sits under this example, which is called cancel on run blocking, something different will occur. Now, run blocking is aware of structured concurrency. So that means if we are running a code that will launch an exception inside a coroutine scope, then run blocking will be aware that there has been a cancellation. So that means that the exception will be propagated all the way up to the run blocking block, and that means that all of this code will throw an exception, which is why when running this example from the specific object that I created to run these examples, the second part of the runtime of the cancel on example needs to run with a run catching, because cancel on run blocking will throw an exception. And we can see that if we run this code right now. The example is exactly the same. The difference is that instead of calling it with a global scope, we are just calling it with run blocking, creating a scope for the coroutines that run inside of it. And on top of that, we are creating all of these coroutines with the context of Dispatchers.io. Let's start the program and see what occurs in the console. Now we can see that the runtime has exited with code 1. this is an indication of an error, a problem. And we can also see that the code never ever got to this point over here. There is no log of the parent thread. There is no log of the current parent thread here or here. And what is interesting also is that it still logs the other two threads of the coroutines running inside the coroutine scope. And they are all running in Dispatchers.io. But the most important part of it is that the run blocking code block will run, and run blocking will wait for it to finish off. And only when it finishes, it will continue. If there is a problem in between, an exception, then the exception will be propagated up to where the call point was, which is this point over here, which eventually means that the program must come to an end with an exception. If I run all of this now from the whole example, then we will have all the logs together and we can better compare the different results. We can see here that the GlobalScope runs up until the end, up until still running. There is no still running block in the second example because the second example runs with run blocking, and run blocking will wait for the scope to complete. Otherwise, it will just throw the exception and propagate it upwards. And this is the reason why the GlobalScope is something that we need to be very much aware of what it is and what it does and what it allows us to do before starting to use it. We can think of it this way. If we want to cancel a coroutine, or if we see that a coroutine is running and that coroutine has the possibility of canceling or just taking too long, or maybe we need to time out that coroutine, or maybe we expect a problem to occur, then it's a really bad idea in those circumstances to use that coroutine with the GlobalScope, which is actually most, if not all, of the possibilities of using coroutines. Yet, if we are just monitoring and we are sure that we don't really have these issues, or if we manage them really well in our GlobalScope usage, then perhaps using the GlobalScope might be a good idea. But again, make sure to watch this video over here, because there I explain in less than 1 minute the possible benefits of using the GlobalScope. Alright, so now it's time to go to the Coroutine Scope, which is the most used scope in the coroutine world, and this is important because we are interested in structured concurrency and cancellation. So let's get into that. So I've created 2 different examples in the meantime so that we can investigate 2 different kinds of scopes at the same time, well, roughly at the same time, that we can create with Kotlin Coroutines. One of them is the Coroutine Scope and the other one is the supervisorScope. Before we can continue into these examples, we need to understand 2 important things about the structured concurrency pattern. When we talk about structured concurrency, we are talking about essentially many different things, but what we want to do is to manage our coroutines in an efficient way, and we want to follow a certain pattern of programming that allows us to manage, for example, cancellation, but also error handling. These are 2 different aspects. At the end of the day, the coroutines do get cancelled, but we have a way to voluntarily cancel coroutines and a way of canceling coroutines if something wrong happens. These are 2 distinct things that we need to know about coroutine scopes. These 2 different coroutine scopes also operate in the following way. If there is an error happening inside the child coroutines, then that will be propagated to the parent. What the coroutine scope does with these exceptions is different in the 2 different cases, but essentially, if there is an exception, one of the coroutines will eventually be cancelled. If we manually cancel the coroutine. It will cancel the current coroutine and all of its child coroutines. So that means it does not get propagated upwards. So important for us to memorize right now is that exceptions and failures propagate upwards from child to parent coroutine, and cancellation propagates downwards from the parent coroutine to the child coroutines. And cancellation, when it occurs, when it is effective, is only during suspension points. So for example, if a coroutine is running and is signaled to cancel, that coroutine will not cancel until it reaches the suspension point. If it's already in a suspension point, it will not return, it will be cancelled. Another important thing is that when coroutines get cancelled, they will send a cancellation exception, they will throw a cancellation exception from the suspension point. So that means if, for example, we are cancelling a coroutine that is running, when that coroutine reaches a suspension point, it will throw an exception. It will throw the cancellation exception. If we are already cancelling a suspended coroutine, then it will throw a cancellation exception on that point. But there is, of course, a difference between a coroutine scope and a supervisor scope. They are both coroutine scopes in a way, but they work a little bit differently. But before we can understand the difference between the supervisor scope and the coroutine scope, it is important for us to see this running in our code examples. But before we check the examples, I want you to know that I've made this video and this video before in the past where I do talk about the supervisor scope. And maybe it's interesting for you to have a look at those videos also to understand a bit better how these things work. But first, let's dive into our code, into the coroutine scope. So I've got an object created here. It's called cancel on coroutine scope. And essentially just launches two different coroutines from a coroutine scope inside a run blocking code block. It is running with Dispatchers.Default. It doesn't really matter which dispatcher we are using at this point. I just want to launch different threads when I am launching these coroutines so that we can understand a bit better how this works. So I am launching here two different coroutines, just as in the same way that we have seen before in several examples. The difference here is that I am launching a coroutine inside a coroutine, and I am printing out when they complete or when they come back from the suspension point, which is the call to delay. In this case, I'm waiting 1 second, and then in the child coroutine, we are waiting 2 seconds. For the second coroutine, we are waiting here 1 second, and then the child waits 1 second. And then in the end, we just print that all coroutines have finished. One question, how long do you think this example will run? For how long do you think it will run, considering what we have already learned at this point from all the other videos that I've made before? 2 seconds, right? Alright, but let's first run the code and see exactly all the printouts so that we get an idea of what it is actually doing at this point. So if I run this code, we see coroutine 1 finished, coroutine 2 finished, and then finally we see coroutine 2.1 finished and coroutine 1.1 finished. This took roughly 2 seconds to run. We can measure this, but it is not the most important part of this example. What I want to do now is to show one thing that I've just mentioned. If we cancel the coroutine scope, the one that I started like this, what we should see is that there will be an exception thrown on the suspension points afterwards. And so one thing that we can do is to go over here and say, let's delay 1 second. Now I've delayed 1 second. This will give us time to run this code over here and this code over here. Then we want to be able to see what happens here and here after running cancellation. But I also want this to run, and I only want the code to fail after this delay. So in that case, let's give it 2 seconds. But I'm not sure if you've noticed, but I'm putting this delay in the wrong place. I'm putting this right after the coroutine scope. So that means that it doesn't matter how much I wait here. At this point, all of this code has already run. So doing anything after these 2 seconds doesn't make any sense. So I need to bring this right over here, inside the scope. I can cancel it from the outside, but it doesn't matter because this is running inside round blocking. So what I want to do is to cancel the scope here at this point. And when it cancels, what will now happen is that there will be an exception thrown only at this point after 2 seconds. And for that, what we will do, we will try here and we will catch the exception being thrown after the runtime returns at this point. So we can now print, for example, that the coroutine 1.1 failed with this exception. So now if we run this code, it should complete and it should cancel this coroutine here. This should never be printed. We should get this printout and it should complete and print all coroutines finished. Let's run the code and see what happens. And we can see with this result that we are actually getting an exit code 1. So what happened here? Now, if you can remember the example of the GlobalScope, we saw that the GlobalScope ignores the results of the coroutine scopes inside of it because it does not recognize structured concurrency anyway. But this one does. So that means that if we are canceling the scope, we are also signaling that there has been a cancellation, and so there is a cancellation exception being thrown. And so the reason why this is failing is because at this point over here at the top, there has been a cancellation exception thrown, and therefore the code fails. If we want this to continue and we want to print out the last statement, then we can just go over here and just try catch this whole body, and here at the bottom we can just say, we can then just catch it, and then now we should be getting our code to run fully because a cancellation exception has been thrown here as well. And now that we catch it, we can now see that the code runs fine and we were able to cancel our coroutine at this point, and we were able to catch the exception from the suspension point that was triggered at this point, because at this point is the point where we called cancel and we decided to cancel our scope. Interesting, huh? We are able, by using cancel, we are able to propagate cancellation from the parent coroutine, which is the one in this bit over here inside the body of the coroutine scope, to all of the child coroutines and make them all cancel. But we also need to be aware that cancellation carries with it the obligation to manage the exception, the cancellation exception. With the supervisorScope, this is exactly the same thing. We will cancel, and cancellation will affect all the sub-childs, will affect all the sub-coroutines. They will all be affected by this cancellation, and they will throw an exception after or during the moment that they are suspended. If they suspend later, the coroutine will continue to run until it gets suspended, and if it is already suspended, it will throw the exception that we have seen here. But what is the difference then between the coroutine scope and the supervisorScope? They appear to do the same thing when it comes to cancellation. Not when there is a failure, because failure propagate upwards, right? And so let's try and do a simulation of that. Let me just revert all of this code, because we did make changes to see how cancellation works, and now we are going to see how an exception works. And so let's simulate a failure in a crucial point in this code. Let's say that, for example, right over here at this point, there is going to be a problem. So we will throw an exception. We will say that coroutine 2.1 failed. Now, IntelliJ is already complaining that this is a dead code, that nothing will appear here. That's fine. We will simply just run this code and see now what happens if this launch and if this throwing of an exception will affect anything in the scope. Remember that here we are waiting 2 seconds, so that means that this exception will occur before the coroutine returns from the suspension point. What would happen here? What is the result of throwing here an exception? And should we try catch this anywhere? We probably need to do that, but I want you to see first what happens now with this code. Now, we do need to try catch it because it gets propagated upwards. But we also see an interesting thing. Coroutine 1 finished, coroutine 2 finished, but this one didn't finish, and this one, of course, did not finish. And we get the exception coroutine 2.1 failed. What is interesting here is that the throwing of this exception did affected the runtime of this coroutine here. But if we do the same thing with the supervisorScope, which doesn't appear to change anything programmatically in our code, we should now see another interesting aspect of cancellation using an exception. What we see here with supervisorScope is that the whole thing finishes. We don't need to try catch anything. There has been a cancellation because of an error. There has been an error here. But we also see that coroutine 1 and its sub-coroutines, all of its childs, were not affected. And that is interesting because what this means is that the cancellation using the throwing of an exception does get propagated upwards. However, it does not affect the whole scope. Instead of affecting the whole scope, it only affects the coroutine that has been affected by the exception, and it does not get propagated further upward in the chain. So that means that this one was cancelled, and only its subchilds will be cancelled. We can do another experiment. What if we throw the exception inside the supervisorScope, but we throw it here? Now it will launch this coroutine, and then it will launch this coroutine, and right afterwards it will throw this exception. But this one is already running. So the question is, do we get to see this coroutine 2.1 finished or not? I think we won't. But I think we will see coroutine 2 finished, but not this printout. Let's see what happens. We do see coroutine 2 finished. We do see coroutine 1.1 finished, just as we believed it would. But we do not get to see coroutine 2.1 finished, because when we threw this exception, all the child coroutines also get cancelled. And of course, because this was already here in a suspension point, it gets immediately cancelled. What could also be interesting here to know is if we are throwing here any kind of cancellation exception. So let's try and see if we get a cancellation exception in this same example with the supervisor scope. So if we print coroutine 2.1 failed, and then we print with cancellation exception, and then we say coroutine 2.1 parent failed, we should now see in the exception logs an error that says coroutine 2.1 parent failed and the exception, and then we should see this one as well, because here there should be a cancellation exception being thrown. Let me see if that is exactly what happens. That is exactly what happens. Coroutine 2.1 failed with cancellation exception. And this is with the supervisor scope. If we now do it again with the coroutine scope, we should see a lot less logs. And I understand that this may be now becoming a bit confusing, but the idea is that we truly understand what we are doing here. If we throw the cancellation exception, at this point we should be able to see these logs in the same way for this coroutine and its sub-coroutines, its child coroutines, but we should also see a difference in coroutine 1, where after 2 seconds, this coroutine 1.1 finished should not appear. Let's see what happens. There we go. 1.1 did not appear. The coroutine 2.1 was cancelled. And the fail appears there just as we have seen before. So there is a try catch here that catches the cancellation exception. It prints out the coroutine 2.1 failed with a cancellation exception, and we see all of this back in our logs. And we see coroutine 2.1 finished because we simply did a try catch over here and we just let the coroutine go in this suspension point. But the scope is already cancelled, which is not something that we see with the supervisor scope, which doesn't get cancelled until we specify that we want to cancel it. Very important to always understand is if we are causing a cancellation of the scope, regardless of if it is a supervisor scope or a coroutine scope, there will be an exception thrown, a cancellation exception, especially if we cancel the parent. The cancellation exception will be thrown from the suspension point. Failures are propagated upwards. Cancellations are propagated downwards. Cancellations happen at suspension points. Coroutines will run if the cancellation occurs while they are running code. At the next suspension point, they will then cancel. Alright, so these are two very important scopes that we can use for server-side programming. How much of these scopes are you going to use? I have to be honest, maybe not too much, because we already get coroutines out of the box with things like Webflux and Project Reactor with coroutines on our Spring framework. Other frameworks are already prepared for it, like for example Ktor. Other alternatives like Quarkus probably will have to work in a similar way with probably libraries that support with coroutines. I'm not entirely sure how you would get this to work with Quarkus, but these are server-side. Now it's time for us to have a look at Android and see how can that work for us. Remember, we still have two scopes to have a look at. One of them is the MainScope and the other one is the viewModelScope. So let's get into that. This is the example I have for you. This example is located on GitHub under my handler J. Espenansinga, and it's called matrix-anywhere-android. This is a simple example. I created this at around 2013, 2014. I don't really remember. And this example application, simply what it does, it calculates the determinant of a matrix we hand in the size of the matrix, then we fill out every single one of those brackets, and then we can just calculate the determinant of a matrix. Now, the goal of this application isn't really necessarily what we are trying to investigate here. What we are trying to have a look at is the main scope, how it works, and what can we do with it. The main scope, to be very honest, isn't something that we will come across a lot in Android applications, because there are other scopes for it. One is the viewModelScope that we mentioned before, and the other one is the lifecycleScope that is also a part of the way Android applications work. But to start out in the Android world, it is good that we have a look at the main scope. Let's just bear in mind one thing. The main scope is not associated to any particular life cycle, and that means that the cancellation of the MainScope coroutines cannot be done automatically. It needs to be done manually. Otherwise, the coroutines will just keep running on the main scope. But before we start looking at the main scope further, we need to understand a couple of things about Android applications if you don't know already. In terms of Android applications, one important thing is that we create an exception handler, especially for coroutines. Because what happens is, if we don't have a coroutine exception handler, or if we are comfortable with not having one, if an exception is thrown during the runtime of a coroutine, then the whole application will fail, and we will potentially miss the benefits of running coroutines inside a main scope. We can discuss in any ways if we should use the main scope in Android applications, but of course here that's what we are trying to learn, how it works. And so here, this is what I have created, a coroutine handler that will just print out the exception that is being thrown, but it will not crash the application. So this will avoid having the application crashing on us, because we also want to see some properties of running coroutines from the main scope, namely what happens with structured concurrency there. Let's now see the main activity of the application. This is the component activity. This is something that is in line with Jetpack Compose. And here what I have created already is a main scope variable that uses the main scope and adds to it the exception handler. As we have seen before, we can use concatenation to establish our context for our coroutines. In this case, I'm only just adding that exception handler so that the application does not crashes there, and that the application gets caught, so that we can see the effects of running the main scope. Now, if we go inside the main scope, we can see another interesting thing, and that is that the main scope runs with a supervisor job in the background. And learning that it runs a supervisor job, you may already have an idea of what this means. We have seen before that a supervisor scope means that we can launch different coroutines from that scope, and the difference from a normal coroutine scope is that when a coroutine encounters a fail, like for example it throws an exception, that failure will only affect that coroutine and it will not affect the other coroutines running on that scope. It will affect its child coroutines, but it will not affect the other coroutines running. And this is something that we can see already that the main scope also provides for us. So that means when we run the main scope, when we run coroutines from the main scope, then we will also have that feature available for us. And that is something that I also done right over here, further to the bottom of the code. Because you see, when I am creating the layout of this application, and when I am starting the activity of this application, I also need to establish how we are going to visualize this application, the different controls and what we can do with the application. And one of the things that we can also do when we are setting up the content of our Android application is to use this launched effect. This is necessary if we want to launch coroutines. But this is a bit off scope for this video, and I will explain this in another video, how this launch effect works. But what's important is that we can launch coroutines from inside of it, and here we would want to affect the contents of a certain control. In this case, we want to affect some text on a certain control. Now, in Android, we can use this by remember, again, off scope of this video, and I will explain this later on another video. And essentially what this means is that we can change the text that a control will use right over here. And this text is important because this is what we're going to pass in as an argument for different functions until we get to over here at the bottom, where we are going to set up the text of the two text boxes of two different rows in our application. That's text and text2. So essentially text1 and text2. If I run this application now, and it's important that we do that so that we have a clear vision of what kind of application is this. Let's just run it. All right, so we've got the application name, and the application is called Matrix Anywhere. And let me just do this. Let me do this a bit big for us so that we can see that we've got not used and used with at the bottom. So it printed out this text, but it didn't print it out this text. What does that mean in our code? Have we seen something weird in our code that does not allow this to happen? That does not allow the not used to be overridden by the actual text that we want to use, which is this one. Well, of course, essentially an exception has been thrown here. And this exception, because the coroutine is being launched via the MainScope, which now has its own exception handler, and added to our MainScope over here. This will now trigger the cancellation of this coroutine, but that's it. It will not trigger the cancellation of this coroutine. So that means that use with at the bottom will still be there available in our application, and this one will never be printed. If we remove this anyways, then our application should be able to run correctly, and we should be able to see that we've got the two different texts that we were looking for in our application. Now the MainScope runs the UI thread, and this means that it should share the same thread at this point and at this point over here. So let's see if that is true. If we print out here to the console, for example, current thread, and then here we print out thread.current thread, and we do the same at this point, we should be getting the same thread, which means that these two are not really launching in parallel. Let's see if that is the case. Let's start the application again. So it has already run, and if we go here to our log, we can see already that both coroutines share the same thread. So that also means that parallelization is not possible using the MainScope, which can be a disadvantage, but that is really what it is bound to. It is bound to the UI thread. And so we only have one thread, unfortunately. If we want to use different threads, if we want to use parallelization, the best thing is to use one of the other coroutine dispatchers. And speaking of dispatchers, which dispatcher do you think that the MainScope runs on? Because we didn't specify the dispatcher. So let's see which dispatcher the MainScope is actually using. And for that, let's just add here to our logs with dispatcher, and then here we're going to say current coroutine context. And let's now copy all of this to here and just rerun the application and see what kind of dispatcher do we get in the logs. Now it has been installed, and if we go here down to the bottom, we will find that we've got a dispatcher here, main activity, standalone, Dispatchers.Main, which should have been no coincidence at this point that we are using the main dispatchers for this scope. So the MainScope uses the main dispatcher. There is only one thread, it is the UI thread. It also uses the supervisor job, meaning that we can cancel the different coroutines independently. But this also means with the MainScope that we have to cancel it manually. And this is something that is done right over here. we need to cancel the main scope manually, because the main scope, if we use it this way, it is not bound to any lifecycle. And this is where scopes like the viewModelScope and the lifecycleScope come in, because they are tied to a lifecycle in the application, different lifecycles. But these lifecycles are things that are more intimately related with Android applications, and for that we need a more thorough video. This video is really about the basic ways of dealing with scopes. I wanted to speak about the viewModelScope in this video, but unfortunately I come to the realization that talking about the viewModelScope and the lifecycleScope in Android is interesting to put in one single video, because there's a lot to talk about there, because we need to talk also about the efficiency of these scopes in our applications and how beneficial they are in different cases when developing Android applications. And of course, the example for those scopes needs to be much more extended than this one that I have over here. So that will be on the next video, and we will talk about these two scopes in much more detail. For now, these were the scopes that I wanted to talk about. We essentially talked about the GlobalScope, the Coroutine Scope, the supervisorScope, the MainScope, and we briefly talked about the viewModelScope and the lifecycleScope. I want you to take from this video the idea that scopes are extremely important for the understanding of how coroutines run in our programs or in our Android applications, and that scopes are different than dispatchers, and that scopes tie all coroutines together in different ways. It is also important for us to understand that a scope gives us the power to perform cancellation of all the coroutines that are bound to it, and that scopes handle in a different way when coroutines fail. When there are exceptions being thrown in the child coroutines, how does that affect the different scopes? It is also important to understand which of these scopes are actually able to handle structured concurrency. We have seen that especially two of them are able to do that. One is the Coroutine Scope and the other one is the supervisorScope. GlobalScope and MainScope are not suited for that. They run coroutines independently, and we need to make sure that we use them very wisely so that we don't get coroutines running in the background, consuming unnecessary amount of resources. Alright, thank you so much for watching this video. Congratulations for reaching this point and for learning more about how coroutine scopes work. Now you know, if you've been watching all of these series, what coroutines are, how they work, what are dispatchers, what are coroutine contexts, what can you do with coroutine contexts, and what are the different scopes, and how does that influence the way we work with structured concurrency principles. In the next video, as I said before, we are having a look at the viewModelScope and the lifecycleScope in Android. And for now, be sure to drop us a like. Don't forget to subscribe to this channel, because I'm always putting new videos about software and software development and programming. Make sure to leave us a comment, because it's important for me also to understand if you have questions, and maybe I can help you there in the comment section with whatever question you may have about the video and about the topics discussed here. And make sure to read the description, because there is where I will put all the different resources that I've used for this video, and I will also put the link to the source codes for this video. One was the GE04 Kotlin test drives, and the other one was this one, the Matrix Anywhere Android. And until the next video, make sure to stay tech, keep programming, be kind, and have a good one. Bye. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.